Hello, welcome to Volkswagen EPC. We have a new project that we're going to be working on today. This is called a GEM car. It stands for Global Electric Motor Car. Now, this car was made by the Daimler Corporation, which is a Chrysler subsidiary, and it comes from the factory with a 72 volt system, DC motor, Curtis controller, and 120 volt charger. There have been some upgrades done to this vehicle already. The DC motor, which was capable of producing 7.5 horsepower, was replaced with an AC motor, which is capable of producing 29.5 horsepower. The controller will handle up to 105 volts. The motor doesn't really care how much power you put to it. The controller can handle up to 550 amps, so it's really not a high amperage type vehicle like a Soliton that we put in the Porsche or something of that nature. But this will be a really fun vehicle when we're done with it. Basically, what we're going to do is we're going to replace the lead acid gel mat batteries with lithium batteries. Now, these batteries that we're going to be using are a little different than your Thunder Skies or your Winstons or your Cal batteries that you get off of the conversion websites. I'd like to show one to you. This is a 200 amp hour lithium battery. As you can see here, it measures 3.3 nominal voltage and goes up to about 4.1 volts when it's fully charged. I like to stop the charge at about 3.65. So we're going to put about 21 to 24 of these batteries in there, provided we can find the physical space to get them in. Now, if we were to cut this battery open, if we were to cut the top off completely all the way around, and then we were to remove it, what we would find in here is 10 pouch batteries stacked on top of each other, all wired in parallel. Each one of those pouch batteries has the same nominal voltage, 3.3 to about 4.1 fully charged, and each pouch battery has about 20 amp hours of capacity. So when you stack 10 of them in here and wire them in parallel, 10 times 20 equals 200 amp hours of capacity. Typically what you can purchase on the conversion sites are 180 amp hour capacity, which is what we've put in the Mazda that we did, as well as the Porsche. So these are going to have a substantial amount of capacity, and hopefully it'll push this little vehicle, which is a lightweight vehicle to begin with. Comes from the factory with the lead acid batteries. Should be able to do 25 miles on a charge up to 35 miles per hour. Now, with this AC motor that's in here and these lithium batteries, we're going to try to get this car to do 45 miles an hour, and we're going to try to get it to do about 60, perhaps even more, on a charge. So we'll see what happens, and you can watch along as I document this conversion on here, one step at a time. But the first thing we have to do is get this thing cleaned up, because the owner parks it in an area where it gets a lot of debris. So let me take you over here and show you. Inside here, the front compartment, you can see there's 2 lead acid batteries here that are going to be removed after we clean it up. And inside the vehicle, underneath the seat, there's 4 lead acid batteries. And then over here you have your charger. which looks very similar to the charger I used in the Mazda, and we're going to be taking that out to take a look at it. So the first thing we want to do here is, as you can see, it's been plugged in and charging. I'm going to unplug it, and we're going to disconnect the power here. Turn that off. That's your main contact, which supplies power from the battery pack. So we want to break that switch so that we can minimize our possibility for shock. So let's get this thing cleaned up and start taking it apart. Okay, so you can see that we have removed the seat, which is basically just sets right on top here with a couple L brackets. And over here you have your charger. Then over here you have your batteries. So we're going to remove this battery here first and work our way that direction and see how much available space we have. So as you can see, we have removed the front cover to the batteries, the two front batteries, and now we're going to start removing the two front batteries. And the way we do that is by disconnecting one terminal at a time and make sure we do it in a completely safe manner. As I've mentioned before in many of my YouTubes, that DC voltage can be very dangerous, so you want to use caution to eliminate any kind of possible shock. And if you do one thing at a time and do it safely, then everything will be fine. It's not as complicated as people think it is. It's more intimidating than anything else. So we're going to go ahead and start removing the front two batteries, and then we'll take it from there. Well, let's see here. What have we found? We have removed two of the batteries underneath the seat, and as you can see, there's still two on this side. After removing the charger, which is right here, I'll just flip this over so you can see it. That's the charger that faces down on top of this battery here. Now, first of all, this negative terminal cap has been melted, so there's been a short in this particular battery location. And this positive terminal post wasn't even covered up. Now the charger is probably less than half an inch away from this positive battery post. In my opinion, this is an unsafe installation. This charger could short out on this battery and could cause some serious problems. So we're going to have to make sure that is not a possibility when we complete this conversion from lead acid to lithium. I wanted to show that to you because my main concern is safety. My second concern is efficiency, and the third concern is reliability. But safety has got to be number one. So let's continue taking out the other batteries, and we'll see what it looks like. Okay, we've went ahead and put some rubber mats down for the batteries to ride on. Now we're going to go ahead and install the batteries and show you what that looks like. Okay, well, we've made a determination on how to mount the battery charger. We decided to mount it inside the battery box, so it's not possible for it to short out on any of the battery terminals. And we're going to be able to read the indicators, or look at the indicators that tell you the state of the charge on the batteries. Now, we decided to mount it in there for safety reasons and user friendly. Now, the drawback is we had to eliminate 3 cells. Now we went down from 24 cells to 21 cells. Now, that's originally what I calculated for this vehicle anyway, was 21 cells. and that'll put it at a voltage of 76.65 when you charge the cells to 3.65. So after looking this over and looking at the controller, which is up underneath the dashboard of the car, you can see it here. It's kind of hard to read it, but basically it says this controller is capable of handling from 48 to 80 volts. This is a Curtis controller. It's a model 1238-6501. And the gentleman that installed this motor in this controller, his name's Bill Ritchie, he instructed me through an email that this controller was capable of handling up to 105 volts. Well, it specifically says right on the nameplate of the controller a maximum of 80 volts. So I don't want to take a chance on overpowering and burning something up. So I think this would be a benefit to everything, to the battery charger, to the terminations on the battery post, for safety reasons, for user friendly of the indicators, and also to prevent overpowering the controller and having a situation where we have to replace the controller. So all in all, I think this is the solution to our installation. Okay, let's keep moving forward and see what we can figure out. Okay, so we've finished building the front battery box that's going to contain 8 lithium batteries, which again are 200 amp hour capacity. And I wanted to build a aluminum box that's going to contain the batteries in the front so that they have some type of physical protection. What came from the factory was a plastic box that had the lead acid batteries in it, and I chose to incorporate this 3/16 aluminum so that we could enclose them and give them some physical protection, due to the fact that the front end on this vehicle is basically just a fiberglass shell. And if you can imagine a front end collision or some type of collision with this, I don't want these batteries to be subject to physical damage. So I want to give them as much protection as possible. And I'm also going to be incorporating some additional support on the substructure here. We're going to be putting some light steel down here in this spot so that we can add some support to it, and it'll give it a little more rigid support in case of any kind of collision. So we're going to go ahead and install the batteries in there and then show you what it looks like. We've got some heavy-duty rubber pads that we put down on the aluminum so the batteries are not riding directly on the metal or the aluminum. We're going to have them riding on rubber insulation. So we're going to go ahead and put that together and then show you what it looks like. Okay, the next thing to do is to put the front panel on the batteries for that physical protection and then wire them up. We're also going to have the charger reprogrammed for the right algorithm for these lithium batteries, since it was originally designed for lead acid batteries. And then we'll wire everything together and turn it on. Okay, let's keep moving.